A plus B, converting it into C plus D. So tell me, what do you think about chemical engineering?
We have to put that up.
As you can see, the biggest difference between chemistry and chemical engineering specifically is that, well, yes, both involve taking some reactants and going from A to D. The chemical engineering involves having to do a complicated process in order to actually produce the desired product, generally for an industrial application. So, for example, usually what you do is you have a lot of different instances where you can do chemical engineering. Say oil, mining, well, products, say from chemicals such as sulfur. You convert it for a process, refinery, factory, or stuff like that. And finally, you turn it into value-added products. In this case, chemical engineers are involved in converting your crude oil into your gasoline, into producing, say, the pharmaceuticals, drugs that you use, and even, say, skincare products. So there's a lot of different things you can do with chemical engineering, and that's kind of our main focus, is taking a product, taking a raw material, and turning it into a final value-added product. Right, so to give you an idea about kind of how processes works, I'll use an analogy that my own professor taught me in making cookies. So for example, the first thing you need whenever you're making anything is the raw materials. So you get your eggs, you get your chocolate chips, your milk, your batter, those kinds of things. Next, you have to measure the exact amount. Because too little sugar and your cookie doesn't taste that good, right? Or it just doesn't come out nice. Finally, you mix together the materials to form a cookie batter, right? Then you bake it, and you have your final product. This kind of demonstrates what a process is, in that it's a series of operations that you do, finding your raw materials, measuring it out, mixing, baking, to form a final product. Throughout this, there's a change of the mass of your product, as well as the amount of energy putting in. For example, baking something requires you putting in energy, whereas measuring and putting it in requires you putting in material into your thing. So this is kind of the idea of chemical engineering in a nutshell, is the processes that involve mass and energy balance. So, as I say, each step is the processes. Now, what about biological engineers? In UBC specifically, chemical and biological engineering offers two different options. There's the chemical process option and the biological process option. The idea of what a biological process engineer does is that instead of using, say, heat or energy or those kinds of things that often require high pressures and can be quite dangerous to produce something, they use cells, biology. For example, your bread that you eat. Basically, the way that bread is made is they use yeast to cause the bread to actually rise when you eat it. So, in a way, biological processes are everywhere, we just don't really realize it. Alright, so finally, just to kind of give you a top of what it is that chemical engineers, people think of and what they do. You know that society thinks you work in an oil refinery. Your friends think you make a ton of money. Your boss thinks you build a bomb. Which it is sometimes. Your family thinks you just do tons of complicated equations, because to them it's pretty much scribbles. I think I just look at pipes with fluid running through them. And finally, mostly I just draw diagrams. So that kind of is an idea of what it is that a chemical engineer does. Let's see. And I guess to kind of top this up, just a quote from Linus Pauling. Only when I began studying chemical engineering did I realize that I myself had discovered something new about the nature of the world. Which is quite true, because just the way you think in chemical engineering, the way that everything works, you get a really different insight into how it is that our whole entire world works. Okay, and finally, if you are interested in actually becoming a chemical engineer, here's kind of the steps to go into here, specifically at UBC. The first thing, of course, you have to do is graduate and apply to UBC engineering. Generally, you may want around an 85 plus average to do that. You survive your first year, and then you choose chemical engineering in your second year. just kind of wait a bit, and if you get accepted, you're in the program. Also, you'll have to do a lot of this as well. But it's kind of worth it. To give you an example, here's a project that we actually work on here in chemical engineering, is the Chemi car. So we basically build a car that's powered and stalled by chemical energy. In this sense, we build kind of a functional fuel cell. So we use, like in lastly, we used an air zinc battery, so it pretty much was powered by air. Also, a lot of food. And just to give you an idea of this kind of stuff we do, this is an example of the process we use to build a printed circuit board that we actually use to control the electronics of the chemical car. Anyways, thank you for taking the time to listen, and if you have any questions, just let me know.